Alright, today we're going to look at what phase shifts are. So in our regular transform sine function generator, we've got A, B, C, and D. We're just going to focus on B and C today. So B is a horizontal compression or expansion. It's what determines our period by 2 pi over B. And C is actually a horizontal translation, and in a trig graph we call that a phase shift. It's basically moving it left or right. So we're not going to deal with A or D. Basically, that means that for now, A is 1 and D is 0. So we are not affecting the vertical values at all. We're just going to deal with the horizontal stuff. So first of all, one that we've seen in class already, let's say if B is 2, that means the period becomes 2 pi over 2, which is pi. So essentially, it repeats itself more quickly, and our quadrants all sort of half each other. So instead of peaking at pi over 2, it actually peaks at pi over 4. In red there, that's our first cycle. And we'll have a second cycle between pi and 2 pi in green. So between 0 and 2 pi, it actually repeats itself twice. Now, if we put a bigger number in there, let's say like 5, so rather than set up my x-axis, I'm just going to figure out the period and know that it's 2 pi over 5. So basically what that means is it repeats itself 5 times as fast. There's going to be 5 cycles between 0 and 2 pi. And the last one we'll look at is, what if we just put a half value in there? If we have a half for B, that means the period actually turns into 4 pi, so it actually stretches out. The period is longer. It's in red and the original is in green. So what about the C value? We said we were going to introduce phase shift, so let's see what happens if we put in a C value of pi over 3. So notice that basically what this means is we are shifting our graph pi over 3 units to the right. So instead of starting at 0, we're going to start at pi over 3, and that pi value is going to turn into 4 pi over 3, and the end value, 2 pi, is going to turn into 7 pi over 3. We can figure out the peaks and the troughs, so pi over 2 is going to turn into 5 pi over, 5 pi over 6 actually. And down at the bottom used to be 3 pi over 2, which is 270 degrees, but we're going to add another pi over 3. Do some lowest common denominator stuff there, think about what those fractions will be. It's going to be 11 pi over 6. So in blue here, we'll put in our little marks and we will connect the dots, and there's our new graph. It's all been shifted over by pi over 3 towards the right, and that blue represents one cycle. Alright, so that was a little messy, so we're going to clean it up and use Desmos so that it looks nice. Computer can do better than I can. Alright, so there's our regular sine graph from 0 to 2 pi. Notice 6.28 is 2 pi. And green there, that's where we get the 2x. And then in purple, that's where we get the 5x. So again, it looks a little messy. Let's just look at one there. There's the purple one. There's the green one. And here's the one with a half. So notice it gets stretched out in orange. The period is twice as big. We could change the domain to 12.56, which is 4 pi. It's going to go a little bit further then. Alright, so we here are going to take a look now. What happens when we do pi over 3? That doesn't work to type pi. We actually have to figure out with the little calculator menu, we got to find pi and put pi over 3. You can see in black there, it's shifted things over by pi over 3 units. Okay. So I took a little screenshot, and now we're going to try to compare it to our hand-drawn graph. So we know it's a phase shift of pi over 3 to the right. And let's just take a little note. Pi over 3 is basically 60 degrees, which is actually around 1 radian, because 1 radian is around 57. So that's why that value is a 1. It's just a little bit past 1 radian. So all of our values, notice, got shifted over by pi over 3. And again, we can put the little marks there. We can see it's the same as what we did by hand, but it's just a nice, smoother curve. It's more accurate. It still ends at 7 pi over 3. And it started at pi over 3. And the important points are to figure out the x-intercepts and then the peaks and the troughs, where it goes to the top and where it goes to the bottom. Notice, had they told us to restrict it between 0 and 2 pi, we could have. It just wouldn't have started right in the middle like we're used to. So it kind of depends on what they're asking us and how we sketch it, if they want one cycle or if they want it between 0 and 2 pi. Alright, so now we're going to take a look at what happens when we when we combine B and C. So a really common thing to do is to just say simply that B is 2 and C is negative pi over 3. It's a common mistake. We have to look at the general equation and know that B is actually factored out from C. So we have to take it and we have to divide pi over 3 by 2. It turns out the phase shift is actually negative pi over 6. Notice it's negative because we're minusing a negative there. That's why there's actually a plus. Maybe pause it there. Convince yourself that you agree with that. That's actually why we're going to go to the left. Pi over 6. And I think I made a mistake there. I did a minus. I'm going to switch that to a plus. And again, this time notice in the red, we've got our compressed graph, the period changes. You can actually put your cursor over those intercepts. It'll tell you what those values are in terms of pi. There we go, just fix this up a little bit. And we might as well put a domain restriction in there from negative pi over 6 to 11 pi over 6. That's kind of the beginning and end of 2 cycles. If we paste this back into OneNote, we will take a look at how this compares to original. So now it starts at negative pi over 6, so it's been shifted over to the left. And we can find a bunch of values there. Normally it was pi over 2, but we're subtracting pi over 6, so that new value is pi over 3. I'm not going to do all of them right now, but you get the idea. Basically, you subtract pi over 6 from all of your regular values, and that represents one cycle. And the second cycle basically happens just after that. And we can see there's sort of an end point at 11 pi over 6, and there's a beginning point at negative pi over 6. So hopefully you find this a little bit helpful for introducing phase shifts, and thanks again for watching.